Hello students. For this session, we shall be talking all about the angle of elevation and the angle of depression. And these are actually the application of triangle trigonometry. So let's move. Okay, when a person looks at something above his or her location, the angle between the line of sight and the horizontal or the eye level is called the angle of elevation. In this case, the line of sight is elevated above the horizontal. So I repeat, if you are the observer and you are looking something, here is your eye level, and you're looking something above your location. Let's say this is the object here. Now, your line of sight and your line of and the level of your eye can form an angle, and that is called the angle of elevation. Okay, I'll give you a more clear picture of that. Suppose the dog is looking at the bird. So you have to remember the following terminologies. We have the eye level of the dog. This is the eye level or the horizontal line. And we also have and looking at the bird. So this is the line of sight. Now, the angle formed between his eye level and his line of sight is what we call the angle of elevation. How about the angle of depression? When a person looks at something below his or her location, the angle between the line of sight and the horizontal or eye level is called the angle of depression. In this case, the line of sight is depressed below the horizontal. So again, if you are here, you are the observer, and here is your eye level, this horizontal line here, and you are looking at the object here, so here is your line of sight. So the angle formed between your eye level and your line of sight is called the angle of depression. Okay, let's say the bird is looking at the dog. So this is the bird's eye level, and the bird is looking at the dog. So the line of sight is this. This angle formed here is what we call the angle of depression. Did you get it? Okay, let's review. Here is the eye level of the dog and also the eye level of the bird. They are both horizontal, isn't it? So can we say that they are parallel to each other? Yes, they are parallel to each other. How about their line of sight? Yes, they are just the same. Now, how about the angles here? What can you say about the angle of depression and the angle of elevation? They are congruent. Why? Let's recall. If these two lines, these two parallel lines, are cut by a transversal, we can create here alternate interior angles. And you have to remember that alternate interior angles are congruent. So we can say that the angle of depression here and the angle of elevation here are congruent. Let's have an example. A man stands at the window of a house so that his eyes are 12.6 meters above the level ground in the vicinity of the house. An object is 58.5 meters away from the house on a line directly beneath the man. Find the angle of depression of the person's line of sight to the object on the ground. So class, you have to copy first the problem before you proceed to the next. So solution. It can be said that the man stands at the window of a house. Let's say this is the house, and here is the man's eye, and his eye level is 12.6 meters above the level ground. This is the level ground, and it is 12.6 meters. Okay, an object here is 58.5 meters away from the house. Now, let's try to find the angle of depression of the person's line of sight to the object on the ground. So you have to remember that this is the eye level. This is the line of sight of the man. And here is the angle of depression. Now, how can we get the angle here? You have to remember that this angle here is also the same as here. So whatever the value of the angle here should also be the angle here. So we can also use this one to get the angle here. Okay, so now what is the angle here? You have to remember first the SOHCAHTOA. You have to apply the trigonometric functions. Now, the most appropriate trigonometric function to use here is what? The tangent function, because this angle here, we have the opposite side, this side here, and the adjacent side. Opposite side and adjacent side. So we have to use the tangent function. And it's equal to tangent theta is equal to opposite is 12.6 over the adjacent, which is 58.5. So to get the angle here, so we have the arctan of this ratio here. So we get approximately 12.15 degrees. So this is angle here also equals here. So therefore, this angle here is also 12.5 at 12.15 degrees. Okay, another example. Calculate the angle of elevation of the line of sight of a person whose eye is 1.7 meters above the ground and is looking at the top of a tree which is 27.5 meters away on a level ground and 18.6 meters high. So you have to copy first the problem before proceeding to the solution on the next video. Okay, you have to sketch. It can be said that the person's eye, this is the eye, is 1.7 meters above the ground here. Now, and is looking at the top of the tree, which is 27.5 meters away on the level ground. and it is 18.6 meters high. Now, so we are going to look into this his eye level and the line of sight here. So now, how do we get the angle here? So we need to subtract first 1.7 from 18.6 meters to get this segment here. So we have 16.9 meters. So to get the answer now, you have to remember the use of SOHCAHTOA. So we have the opposite and we have the adjacent. So we can apply the tangent function. So we have tangent theta equals the opposite, which is 16.9 meters, over the adjacent, which is 27.5 meters. So we have the angle here is approximately 31.57 degrees. So the angle of elevation of this person line of sight is 31.757 degrees. Okay, let's say this is the problem. The object is 100 meters away on the levergram, and the angle of depression here is 50 degrees. Now, we try to find the height of the man in the hot air balloon from the ground. So we know that this angle here equals the angle here. So we can say that this is also 50 degrees. So now, how to get the height here? So remember again the SOHCAHTOA. So we get tangent 50 degrees equals the opposite, which is h, over the adjacent, which is 100. So to get the height here, we just multiply tangent 50 degrees and 100. So we get approximately 119.18. So therefore, the height of the man in the hot air balloon from the ground is 119.18. Okay, another example. Find the height of the tower in this diagram. We have the angle of elevation 80 degrees and the hypotenuse here is 53, and we are to get the height. So you have to remember again the SOHCAHTOA. So if this is the angle here and we are looking to the opposite given the hypotenuse, so we can apply the sine function because we are looking for the, what do you call this, the opposite side given the hypotenuse. So sine 80 degrees is equal to opposite, which is h, over the hypotenuse 53. So the same procedure, we just multiply 53 and sine 80 degrees. So we have, so the height here is approximately or equal to 52.19 meters. So thank you.